All right, let's see if I can hit the right button here. Look at that. All right, well, thanks to all of you for being here. It's nice to be here at my very first Linaro Connect event. We'll see if I get invited back after I've been through this. I would say there are some seats up here for all the folks standing in the back if you wanted to come up. The interesting part of the talk is later, so you can, I would encourage you to come and sit down, honestly, rather than stand back there. I'm calling this talk Mobile in the Driver's Seat because I want to talk about mobile and embedded Linux being in control of the system. I'm not talking about in-vehicle infotainment. It's not going to be another one of those talks, so you can not worry about that. And this was driven by an observation I have made many times over the years when I have been talking to people about how one could use Linux in an embedded setting, and I've been told by the person I'm talking to, oh, but the enterprise people are in charge of that. Linux is developed for the interests of the enterprise computing market and nothing else. It's really not suitable for those of us in the mobile and the embedded world. It's too bloated, it doesn't manage power right, it doesn't handle our hardware, all these sorts of things. And I still hear this every now and then, despite the fact that we seem to be kind of taking over the mobile and embedded markets. So what I want to ask about explore was this true over the years when people were saying this? And perhaps more to the point, is this true now? So what we're going to do is have the world's most superficial history lesson here. We'll go back to 1991, right? Certainly nobody can argue that in 1991, the enterprise computing people were in charge. It was, throw it out there, it's 10,000 lines of code in the kernel. It maybe works, it maybe doesn't, but people start playing with it and start doing interesting things with it. And so it was very much a hobbyist world at the beginning, just like everybody said it was once upon a time. But that didn't last very long, and the turning point that I have picked out, other people may differ, was actually in 1994, when the folks at Digital Equipment Corporation decided to donate an alpha to Linus to port Linux to it. This is the first time we had a company saying, hey, this would actually be useful. If this operating system were running on our hardware, we might actually get some business out of that. And the objectives at the time were minimal. All right, they wanted something that didn't crash and could maybe talk to the world. But the people working on it did, in fact, move on to bigger and better things over time. So from there, we saw an increase in interest from what you could think of as the enterprise world. And somewhere around 1998-ish or 1999, when this particular picture was taken, you can't really see it very well here. This is the laser light show at the very first Linux World Conference, which was very much an enterprise world at that point. We had people aiming for that particular market, a whole lot of money going into that. That is where Linux was being pushed at that time. So at that point, we can say that, yes, in fact, the enterprise people had taken over the show. And so why was that? One reason, of course, is that there was already a well-established market there. There was the Unix enterprise market that was well-established, making a lot of money, and in the process of dying at that time. Unix was being pushed out of it. There was kind of a gap there because none of us actually really wanted to switch to Windows NT in those days. And so Linux came along and saved us all, and it was really a great thing. So the market was there. The necessary software was there because the applications that you needed in those days had names like SendMail and Apache, and then eventually things like Oracle and so on. Again, we already had all the applications from the Unix world, and they were pretty easy to port over. And so life was pretty easy in that regard. But the point that I really want to make here is that the reason that Linux succeeded in this area was because the companies that were involved took responsibility for making it work really well. If you remember the system that we had back, around 1998, 2000, something like that, we were awfully proud of what we had built in those days, but it actually kind of sucked. It didn't work very well, certainly not compared to what we have now. There was a whole lot of stuff that needed to be done throughout the whole kernel. And the companies that were making money in this area said, okay, we are going to take the responsibility. We are going to do this. And so you had the Red Hats and the IBMs and the SUSE Novells, companies like that, putting a lot of resources into making Linux work well in this particular environment. And so the result was indeed a kernel that was designed for and buy the enterprise computing market. Right? That was really where the interest was. And as a result, they inflicted all kinds of terrible things on those of us in the mobile and embedded computing world. They shoved symmetric multiprocessing down our throats, for example. And they supported support for more than 1 gigabyte of memory on a 32-bit system. This was a big-time, big iron problem. And very controversial, because only the big iron people needed it at that time. Right? They added things like enterprise-class file systems, completely fair scheduler, best-of-breed networking, all this sort of stuff that was pushed on us by the enterprise market, and all of which, of course, is now very highly relevant to this here 4-processor, 2-gigabyte device that I carry in my pocket and runs with an ARM processor in it. So yes, in a sense, it was dominated by that market, but those people built something that is now very useful for the mobile and embedded world. And a whole lot more that goes with that. And the point that I want to make is that the best thing they gave us was the kernel development model. The reason that we have all of this stuff and can use it in our handsets and whatever is because the enterprise computing people developed it for the single Linux kernel. And they put it all upstream, and they put it all there where we can all use it, and we can all drive it in the directions that we want to go. And the process, they gave us a whole development model that went with this. Part of it comes here. This is an old slide that I put up for the 20th anniversary a couple of years ago. Lines of code, all that. The main thing I want to point out really is just the way the release history looks, and how we went from kind of traditional even, odd, stable, unstable model, where we went as far as 3 years between releases, to something where we now have releases coming out like clockwork about every 80 days. Can you imagine trying to make things work in consumer electronics or wherever if kernel releases were 3 or 4 years apart? It would not work very well at all. So in the process of making things work in the enterprise world, they came up with a development model that worked. And the biggest part of all, the biggest gift that came from the enterprise people is what is often called the upstream first rule. That says, essentially, you do not ship code to your customers until you have put it into the upstream kernel, or at least you have it well on the way towards getting there. Right? It was expressed a little bit differently by Andrew Morton in a keynote at the Ottawa Linux Symposium many years ago. I think this was about 2005. Where he said that he saw the perfectly understandable vendor strategy of offering product differentiation at the kernel level as being in direct conflict with the long-term interests of Linux. And he went on to add that he would actively work to undermine that model. This was really taken to heart. And if you look at the way development was done in the enterprise market, it really followed the rules that Andrew tried to set down, where things did go upstream first, and it was there in the mainline kernel for all of us to use. And that is why we have the kernel that we have now with the functionality that it has. That is why we have a kernel that is, what, about 22 years old now, and is still a vital software project. And in fact, it is the most vital and the most healthy that it has ever been after all of these years. It has a lot to do with the fact that this particular rule was followed here. Now, I will come back to this. But I want to take a little detour now and say that while enterprise was running the show, while all of this stuff was going on at the enterprise level, some people were starting to play around with Linux on the margins and think, okay, what can we do with this software? So I went a little while back and tried to figure out what was the first embedded Linux product ever. And it turned out that I actually had one of them at the time, because Wikipedia tells me that it was the Axis camera. I believe it's the 2100. And it's on Wikipedia, so it's got to be true. Right, this was a nice little webcam type device that actually had a full system in it. It had its very own web server. So you just plugged an Ethernet jack into the back of it, and you had something on there. Of course, this was about 2000, so it was about this big. But it seemed awfully cool at the time. But that was where it started. That was evidently the first shipping product with Linux built into it. And of course, a whole lot went into it after that. And we entered what I am choosing to call, at this point, the toddler stage of mobile and embedded Linux, where we were just getting started with this stuff. So there's a lot of things that you might associate with toddler-type behavior, such as taking a whole lot of stuff without giving back, right? Toddlers want things. And so if you think about how embedded Linux worked in those days, there was a whole lot of taking Linux. There wasn't a whole lot giving back to it and making Linux work better or supporting the community that had built the system that was out there. Fair amount of supervision and nagging and parenting was required. This is Thomas Gleitzner, the 2007 Embedded Linux Conference, where he came and gave a talk that he called the Embedded Linux Nightmare. That was his term. And he was talking about the way that the embedded community was working, that it was not working with our own development community, and all the sorts of problems that resulted from that. And he was there trying to browbeat people into doing things better. If you know Thomas, you know he browbeats very effectively. And it worked fairly well. We had a lot of sort of ups and downs and tantrums and complaints and fights and so on, the sort of stuff that happens as you grow up. But the main thing that we had was getting out there and doing what toddlers do. Learn the world, fall down, bonk your head a whole bunch of times, learn the things that you need to do, and slowly learn how to work in the world that you're in. And in fact, that's what happened. And so we moved into something that we can think of as being something closer to adolescence. So what happens as you grow up and you become a teenager, somebody at that stage of life? Well, you start to learn how to work in the world. You start to learn your responsibilities, and you start to decide, think about how it is that you might want to change the world. And so we see this going on in a lot of ways. This is a plot that I've been putting up for a little while now. What we're looking at is kernel releases from about 2.6.26, 5 years or so ago. And the lines are simply the percentage of change coming from various companies that have been actively participating in this area for a while. So you see a lot of, in a very noisy way, horizontal lines representing the contributions of companies like Red Hat and IBM and so on. The lines that are thicker down there at the bottom correspond instead to TI, to Samsung, and to Linaro. And so there's a very obvious trend going on here. We're seeing starting right around 2.6.30 and then picking up from there. We're seeing a market increase in the amount of contributions coming from just a few companies in the mobile embedded world, and there's a whole lot of other ones as well. If you add them all up, it now adds up to a significant percentage of all the code going into the mainline kernel. This is a great thing. This is a community that is really deciding to pick up its responsibilities and to do what needs to be done to get the kernel to where it needs to be. Now, if we're still sort of going with the adolescent metaphor, then you can start to think, well, okay, you start to pick things up, but things still tend to be a little bit messy every now and then. So you can think about what happened to the ARM architecture subtree as all this was going on. And it looked very much like a teenager's room at that point. You know, everything just kind of thrown in and it landed where it did and so on, until the parent, in this case being Linus, had to throw a tantrum and say, okay, you guys are going to have to clean up your room right now. You don't get to go out and play. You can't have the car until you've cleaned up your mess. And so, in fact, that happened. And so we see basically that the world is growing up here. So the ARM subtree has been cleaned up. ARM64, ARMv8 has been done right from the outset. Lots of nice abstractions going to the kernel. It looks like things are really going a whole lot better. Things are being done right. The situation has improved hugely, and that's due greatly to the work of the people in this room and beyond. All of you have done, a lot of people have done a lot of really great work, and the results are really great. They include, among other things, of course, huge success in the market, as we were hearing about before, and as we will hear about going on into the future. Things are really going pretty well. But I would like to, at this point, go back to my original question, which is, who is Linux developed for now? Is it still the case that Linux is developed for the enterprise market, or has something changed here? And if so, what has changed? So I just went and I dig through. People know that I like to dig through the kernel source tree and see what's going on in various places. So if you look at about 1 year, actually a little bit more, closer to a year and a half of history, from the 3.3 kernel through a ways into the current merge window, which just ended about an hour ago, by the way, and you see that in the ARM subtrees, a bunch of companies are contributing that would be pretty much what you would expect to see. You see Linaro at the top of that list now, TI, consultants, ARM itself, NVIDIA, Samsung. There's really not a whole lot of surprises there. These are the folks you would expect to see contributing to something having to do with ARM. Okay, but this is only a piece of the kernel. What if you look at other parts of the kernel? And in particular, I wanted to look at who is hacking on the core kernel. Who is hacking on the main part of the kernel that drives everything else, that controls how everything else goes. And for the same period of time, this is still from 3.3 going forward, you see a very different list of companies here, right? Headed up by Red Hat. Red Hat, by the way, doesn't appear on this list at all. If you wanted to put Red Hat on this list, it would be down there somewhere well underground at this point. For all of Red Hat's fairly loud involvement in ARM, it's at the higher levels. They aren't really doing much at the kernel level. Okay, but if you look at the core kernel, you still see the enterprise distributors at the top of the list. You see enterprise storage companies like NetApp and so on. You see Google. Google, we're starting to see more out of the mobile side of Google, but most of the code coming out of the Google is still coming from the data center side and reflecting the needs of that part of the operation there. You see virtualization companies. You see companies like IBM and Oracle, which you just don't really think of as being mobile companies, and so on. And you have to get way down here till you see anything representing the folks in this room. And so you say, okay, 4% coming from Linaro. This is a good thing. And yeah, it is a good thing, but I feel the need to quibble just a little bit with this number, because about half of those changes credited to Linaro are to the read, copy, update subsystem, not really a hugely mobile sensitive area of the kernel, contributed by a single IBM developer who's in fact no longer working with Linaro. So if you take those out, then what happens is Linaro would actually fall off that list. And you wouldn't see anybody really on that list at all, except for maybe Intel, which you can think of as trying to work somewhere in this area. But Intel, for all the great work they do, cannot necessarily be counted on to further the interests of the ARM community, shall we say. So the claim that I will make is that the enterprise people are still running this show. If you look at the core kernel, it is not the mobile and embedded people who are developing the core kernel, right? This is still being done by a very different group of developers here at this point. And I want to look for just a moment about how this comes about, why that is, and try to do just a little bit of browbeating of my own to see if we can make that change a bit, because I think it needs to change. And I need to start with an apology, because what I'm going to do is I'm going to pound just a little bit on the big.little patches. I'm going to pick on them. And I'm going to do this despite the fact that I think it's really cool work. I think the big.little switcher is a great hack, making some very interesting hardware actually work for people. I think the big.little MP work is really interesting work. I think it's great work, but I'm still going to quibble with it just a little bit. So what I've put up here is a diffstat listing from one of Nico's postings about the big.little patch set, just showing where the changes are being made for this particular patch set. And if you look at it, you see here there's a file and documentation. That's pretty good. And then you see everything is in Arch/ARM. Okay, it's all in the ARM subtree, and really nowhere else except for a couple of include files, just a little bit of driver work.
That's my old sandbox.
Yes, exactly. Exactly. This is the sandbox, but this is a scheduling problem. We're trying to figure out how to schedule tasks on a heterogeneous asymmetric multiprocessing system. And we're doing it all outside of the scheduler code. It's being done all in the ARM subtree. It doesn't touch the scheduler at all. And one can argue, okay, this is a short-term hack. We're just trying to make this hardware work at this point. There are other solutions that are going to try to do it right. And one can say this, but if anybody tries to tell me that 5 years, 10 years from now, that big.little switcher code won't be used by people, I will disagree with you, because I know better. I've seen how this goes. Right, that code's going to be with us for a long time. And it has been done in a way that avoids the code that actually needs to be touched for this. And I have to complain, because this code has not been publicly posted, right? People in this room may have seen it. We've seen some of it. We've seen the multi-cluster power management code, which is cool. But we have not seen the big.little switcher. It has not been publicly posted. Now, at ELC, it was evidently said that it will be publicly posted sometime after somebody has, some Linaro member has shipped hardware with it in there, and so on. And okay, that's fine. But if you say something like that, you should feel Andrew Morton's beady eyes staring into you. at this point. Because this is exactly what he said was contrary to the long-term interests of the Linux system. This is it, exactly, right here. Okay, this code will be shipped to people before it is publicly seen. So we will see a lot of the same things that we've seen with the Android code, right? There will be integration problems. There will be merging problems. It may not get into the mainline kernel in anything resembling the form that it has been shipped by these vendors. We're repeating something that we have seen before. And I really wish that it weren't being done that way. Okay, this is not really upstream development. This is a code dump. And that's not, I think, the right way to do this. Okay, let's move on and look for a moment at the big. LITTLE MP code. This is now the diff stat for the big. LITTLE MP development. And if you look at it, you do in fact see something a whole lot different. All right, the biggest change here is in the core code now. This is in the scheduler code. So this is good. This means that now we're actually trying to solve the problem in the right place. And this is great, but this code has never been publicly posted. If you know where the Git tree is, you can look at it. I know where the Git tree is. I have a copy of this code. But if you don't follow a particular Linaro mailing list, you probably don't know where that Git tree is. And in particular, I don't believe that any of the core scheduler developers know where that Git tree is. I don't believe any of them have ever seen it. None of them are credited in it. There's no reviews. There's no comments. There's nothing like that. They haven't seen it. So there's going to be an interesting thing that happens when they do see it. And in fact, this has already been kind of foreshadowed on card 190 that I found as I was searching through the Linaro web pages on all this sort of stuff, saying that getting acceptance for changes can require several iterations. More scrutiny than usual can be expected. So somebody knows what's coming here, right? This code has been developed. It's interesting code, but it's not going to go into the mainline in anything resembling the form that it is in now. That is just normal. That is to be expected. That's the way it works. I'd also like to point out, this is very much an outsider perspective on doing core kernel work. This is, we've done it, now we're going to have to somehow get it past those other people, as opposed to, we are core kernel developers, and we are going to make the core kernel work the way it's supposed to be. So I tried to figure out something about when this code might be posted and how this scrutiny might happen, and I found this. Again, on the Linaro website. And I have to say I came away not a whole lot wiser than I was before. I still don't really know how this code is actually going to get into the kernel development process at all. And I'm not the only one. And so I hate to put this up, but this came out just a couple of weeks ago. And it was posted on a very large, very high-profile mailing list by the main core ARM developer, saying that Linaro connects are a bad idea. It gives the decisions being made and finalized, but it's done outside of the community. And he put it as being, it could be viewed as a corporate takeover of open source. Now, anybody who knows this particular person knows that you have to calibrate his remarks a little bit. Right? And you don't always take them literally. But even so, this is not good, okay? You don't want to see this kind of discussion happening on one of the main lists. This is not the way to exercise control over how the kernel as a whole goes. So this is kind of what I came here to say, was that perhaps things can be just a little bit different here. Maybe it really is time for the mobile and embedded people to be running the show and not trying to get those other folks to take their changes maybe someday later on. So I would like to ask people, as you think about things, as you talk about these various developments over the course of this week, think about solving the problems where they need to be solved. Develop core kernel code. This is your core kernel as much as it is anybody else's, right? This is not some sort of immutable platform that you are trying to develop onto. It is yours. It is something that can be driven in the directions that you need it to go. And if you want this kernel to be doing what you need it to do 5, 10 years from now, you need to drive the core kernel where it needs to go. It's time to come out of your messy room and to work with the rest of the community and become part of the core kernel, right? Do that work in public. I talked about that, don't need to go on. And involve the core kernel developers early on in the process. But more to the point, and this is really kind of my whole point right here, be core kernel developers. This is our kernel. This is not the enterprise's kernel that somehow mobile and embedded get to use because the enterprise people are nice and they let them do it, right? This is a kernel that is developed by the community that takes an interest in developing it. And the more that people go and they drive the core where they want it to be, then the better off we will all be. So that's my main point. And I have a couple minutes, so I have a couple of other things to kind of utilize the bully pulpit for. And maybe there'll be a moment or two for a question or two if people want, I don't know. So I had just a couple of things I wanted to throw out there. We heard this morning talk about security and all that. And so I'd like to make the point that this kind of thing does not help at all. And before anybody thinks that I'm picking on you, anybody who has seen me give talks knows that I have made this point in a lot of places. I've said this at the Kernel Summit. I have said this at the Linux Plumbers Conference. I've said this in a whole lot of places. The security game is played for keeps. The people who are out there are serious in terms of the attacks that they're trying to make, the way they're trying to get into our systems. And as we take systems and we carry them in our pockets, eventually perhaps in our bodies, we don't want our heart rates to be broadcast to the world or controlled from the world. Seriously, right? So we're on the front line and we've got to be serious about this. And I keep making this point because it's a hard problem. And we all have to do it. As we talk about differentiation and so on, the enterprise market mostly managed to get past the binary blob thing. It took us a long time, but we did it, and the kernel is much better for it. We need to outgrow it here as well. The time for binary blobs is past, honestly. We'll have a better kernel for all of the mobile and embedded community when we take that stuff out. And the final thing I want to say just has to do with lockdown systems. There's a lot of creativity in this room and beyond, but it doesn't stop here. People at the Embedded Linux conference heard about some developers from NASA using a Nexus S smartphone to control robots flying in the International Space Station. And they were able to repurpose this hardware for really bizarre things because it was not locked down. They were able to do that. There are people who are rewriting the firmware on Canon digital SLR cameras because there's an ARM processor in there and they can do this and make it do all kinds of things and make this hardware much more valuable than it was when it left the factory. So there's been great trends in this direction. I hope they continue. But again, the main thing that I came here to say is that mobile and embedded have grown up. There's a whole lot for everybody in this room and beyond to be most proud of. The core kernel needs you. And let's work to develop the whole kernel and to drive the whole kernel in the right direction so that 5 or 10 years from now, when the new young kids are coming up and doing whatever cool, unimaginable thing is that they come up with at that point, they'll be whining that they can't really get what they want because the kernel is driven by those mobile and embedded folks, and it suits their needs. And I'm really looking forward to that day. And with that, I would like to thank you all very much.